Hello, let's continue our Sudoku adventure with 5 gold rings by Calvinball. So, we have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these 2 quadruples in the grid. These are these circles that touch 4 cells. The digits that appear in the circle must appear at least once each in the surrounding 4 cells. So I could do, say, a 1 here and a 4 here, or I could do a 1, 4 like this, or I could do 1, 4 like this, as long as they appear once. What I can't do is like 1, 2, 3, 5, because even though the 1 appears, the 4 does not. So this violates our quad. So here we need, and if a digit appears twice, a digit must appear at least as many times as it appears in the circle. So 1, 2, 2, 5 tells us that we need maybe like 2, 1, 2, 5, 2, like that. That's not the only way to do it, but that would be one way to fill this. If I tried to only put 1, 2, that still violates the quad. We need 2 2s or more. In addition to that, we have these gold rings in the grid, 5 of them. These are just Renban lines masked as gold rings. So digits on a ring form a set of non-repeating consecutive digits in any order. So for example, we could do 2, 3, 4, 5. 2, 3, 4, 5 is a run of consecutive digits. They don't repeat. What I can't do is 1, 3, 4, 5, because 1, 3, 4, 5 is not a run of consecutive digits. So the order doesn't matter, but if you take all the digits on it, we need to end up with a fully consecutive run of digits. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, well, we know that this is made up of only 1s, 2s, and 5s, and there's either a 2, 2 here or a 2, 2 here. So that tells me that this Renban does not have a 2 on it, because we've already used up all the 2s. In fact, the 2 for this box is in one of these 2. Without a 2 on here, then we have to... Okay, so let's think about it this way. So a 4-cell Renban is going to be 1, 2, 3, 4, 2, 3, 4, 5, or 3, 4, 5, 6. But one way to think about it is, what are the 2 digits that are missing? And the point is we have to be missing 2 consecutive digits, but we can span that 1 to 6 as if it was toroidal. So as if 1 and 6 were consecutive. So we can be missing the 1 and the 2. We can be missing the 1 and the 6. Let me write this out. We can be missing 1, 2. We can be missing 1, 6, or we can be missing 5, 6. That's it. Those are the possible 2 digits that are missing. And those 2 digits that are missing goes over here. Now you'll notice that there is only one of these that uses a 2. So basically if the 2 is missing, we also have to include the 1. And so this is a 1, 2 pair, and then this is 3, 4, 5, 6. So that is actually going to use up all the 5s in these 2 columns. One of them's on the ring and one of them is in this quad. So these aren't 5, for what it's worth. Now 1, 2, 5. We know one of these is 2. We know one of these is 2, right? So 2, 5 is possible. No, yeah, this would be a 3, 4. So there's 2 options. Either this is 1, 2, making this a 3, 4, or it's 2, 5, making this a 3, 4. Oh, wow. So it's always 3, 4. Yeah, if this is 1, 2, we only have one option for doing 4 consecutive digits. It's 1, 2, 3, 4. If we do 1, 5, we have to fill, if we do 2, 5, we have to fill the gap between 2 and 5, which means the 3 and the 4. So this is always 3, 4, which means the 6 is always over here. Okay. So 3 and 4 are both here somewhere. 1 and 4 in here is doing something. Okay, what about this ring? It's got a 1 or a 2 on it, which means it cannot have a 6 on it, right? We can't bridge the gap between 2 and 6. We would need 3 digits. We need 3, 4, and 5. So this is not a 6. Now, we could do 2, 5 with a 3, 4 here. If this was a 1, we'd have to be with the 3 or the 4. Oh, interesting. So remember that the 2s are used up here. These can't be 2s. They also can't be 5s. So let's actually write this out. They're not 2s, they're not 5s, right? The 5s are used here, and the 2s are used all within here. So from 1 through 6, they can't be 2, 5. Now, this also can't be a 6 because it's on this ring. Now, that means that if there's going to be a 2 on the ring, it's going to be exactly here, because this 1, 2 pair, these are actually just 3, 4, 5, because they can't be 6 and they can't be 1, 2. So my point is that if there's a 2 on the ring, it's right here. So if there's a 1 on the ring, it can't be here. Because if there's a 1 on the ring, if this is a 1, we are expecting a 2 somewhere on the ring, and there wouldn't be able to be. So this actually is the only place for 2, and that is the 2. Sorry, I guess I should say this can't be a 1, therefore it is a 2. That's 2, that's 1. And so there could be a 1 on the ring with a 3, 4 pair. Or there could be a 5 on the ring with this being 3 or 4. Yeah, I'm not sure if we can resolve that at the moment. So there's a 1 on one of these two for the quad. What about these rings? Do we need to do something about this? So we know that, again, the digits missing from the ring are either 1, 2, 1, 6, or 5, 6. So these are only from 1, 2, 5, 6. I guess I should say that, right, that this is something that would have been useful to use earlier, but I didn't mention it, is that a 4-cell Renban must have 3 and 4 on it, right? That's kind of the corollary, right? It can only be missing 1, 2, 5, 6. So it must contain a 3 and a 4. So this ring needs a 3 and a 4. This ring needs a 3 and 4. That's why this had to be 3, 4. That was a much simpler deduction, is that this ring always needed a 3, 4, which had to be down here. This ring needs a 3 and a 4, which are going to be in some way in these 3 cells, along with a 1 or a 5. So if this isn't a 3, 4 pair, this is a 3, 4. I'm not sure if that's a problem. I'm just trying to figure out, do we color 3, 4s somehow? We may be able to do something with 3, 4 coloring. So let's call this 3, 4 green and this 3, 4 purple. So we need a green and a purple on every single ring. Right, so where does this ring get green? Right, this is 2, it's not green, and there's already a green in this column. So what if this ends up 3, green is 3. If this ends up 4, green is 4. We don't know which, but this is controlling what green means. And we know that this ring needs a green, and it ends up exactly here, so it can't actually be 5. And so that means green is in one of these two up here. We also know purple's in one of these two in this box here, which means this can't be green and it can't be purple, because the purples are pointing down from this box. So if it's not green and it's not purple, it can't be a 3, 4. It must be a 1. So let's clean up all these 1s. This now has to be the 1 for this quad. And now this is 2, this is 2, this is 5. All right. And this is the purple 3, 4, which I was going to point out later. Here's our 6. These aren't 6, these aren't 5. All right, so this is only 3 or 4, so it has to be the purple 3, 4, which means that green and purple are used, so this has to be 6. Over here, this isn't 1, 6, this isn't 2, 5. Interesting. So we're missing one end or the other. We're not missing 1, 6 from this. I'm not sure how much that helps. 2 and 5 go up here. 1 and 6 go down here. That's really interesting. All right. Yeah, this is another way of saying we're extreme, is that we know a 1 or a 6 appears down here, which forces this to be extreme, either 1, 2, 3, 4 or 3, 4, 5, 6. All right, what else can I do? Can I do more with coloring? Oh, we know this is a 5, 6 pair. That's helpful. So we know this ring needs a green on it. It's going to be one of these two. And it needs a purple on it, which is going to be one of these two. This ring needs a green and a purple. It's not going to get a purple here. It's going to get a purple down here. So the purple 3, 4 definitely ends up on this ring. The 4 that goes on this quad, it has a color. It's either going to be purple or green. I don't know which. There's a 6 down here. There's a 2 up here. It's got to be something to do with these rings that I'm not thinking about. It's either 1, 2, 3, 4, or it's 3, 4, 5, 6. So these cells here have the 2 or the 5, whichever one doesn't go here, plus purple. So this is The 2-5 that's not here plus purple go here. And then down here, it's the 1-6 that isn't here plus green. I don't know if that's like at all a useful way to think about it. I think the overlap between these two might be key, but I'm not sure. So we have two options. Either this is green, in which case this is also green. Ooh. Actually, is that going to do it? I don't know. It's not quite. So in that case, okay, in this case, if this is green, then we can't put another green on this ring. And so in this row, green ends up here. So we'd have green and green. And what I'm thinking is that means that green isn't in this 1-4 quad, meaning green can't be 4, so green would be 3. So the only other option is green is here on this ring, in which case this ring still needs a green, so it would join the purple here. It would be a green-purple pair. So no matter what, there's no greens here. These can't be green. And this, we already knew this couldn't be green, but I don't know if that's helpful. I don't know. These can't be 1 or 2. Is that? I mean, these are 3, 4, 5, 6. For what it's worth. These are never 6. If we try to put a 6 down here, then this has to be a 1, and we can't bridge 1 to 6, right? This is the extreme. We can't put more 1s or 6s on here. So these are not 6. And in fact, that's actually a really good and important deduction. We can't make this a 1-6 pair on the same ring. That doesn't work. And so where does we know that 1 and 6 go down here somewhere, but they don't go here. Because this ring can't have two 1-6s on it. So the other 1-6 goes here, and that we know that's not green. That makes this green. And like I said, now that this already has a green on it, it can't have another green. So this row needs a green, and it ends up here, or the box. And so this is green. And now we know, actually, that green does not go on this quad, but the quad needs a 4 on it. So that means green can't be 4. So green is actually 3, and purple is 4. Okay. So this is where the 6 goes in the row. This is 5. So I don't need my colors anymore. Let me just make sure I know that 4 is one of those two. All right. Don't need the colors anymore. So this is 3, 4, 5. So it can't go with a 1. We don't have a 2 on it. So this is a 6, and that's a 1. And now this is 1, 2, 3, 4. So this is 2, 4, and this is our 5. That gives us 4 and 5 here, 1 here. This was a really interesting use of a quad here to force green to be 3. That was really interesting. This is 1, 2, 6. The 1 goes here. This is a 2, 6 pair. 2 in this column goes here. This is the 3, giving us 5 and 3. All right. This is known. This is a 6, giving us 2 and 6 and 4 and 2 and 4 and 5. And we're done. All right. That was a neat puzzle, Calvinball. I actually really liked the Renban logic in this one. Especially the ending here with these two rings, at least the way I thought about it was really neat. I don't know if there was another way to think about it, but yeah, the key deduction here was putting a 1-6 only cell on here. Not only forced this to be extreme, but it prevented another 1-6 from appearing on the Renban. And that was the most important deduction, I think. Cool. Well, let me know how you did. And if you enjoyed this, want to leave a like, subscribe, and a kind comment below.